Electricity is everywhere around us, but the way we generate it has not changed as much as people think. Most modern power systems still rely on a simple principle: mechanical energy spins a generator, and that generator produces electricity. Whether the source is coal, water, wind, or nuclear energy, the basic structure remains the same. More than a century ago, Nikola Tesla explored ideas that questioned whether electricity always needed to be generated this way. Some of his experiments suggested that electrical energy might be accessed or transferred using different methods than traditional generators. Understanding what Tesla was trying to do requires looking at the scientific environment of his time and the problems engineers were trying to solve. During the late 19th century, electricity was rapidly becoming part of everyday life. Cities were installing lighting systems, factories were beginning to use electric motors, and engineers were working to expand power networks. However, electrical systems were still limited by infrastructure. Power plants had to generate electricity in one place and then deliver it through wires across long distances. This required expensive equipment, complex networks of cables, and constant maintenance. Transmission losses were also a concern. As electricity traveled through wires, some energy was always lost as heat. Tesla believed there might be ways to reduce or even bypass some of these limitations. His work on alternating current had already demonstrated that electricity could be transmitted over longer distances more efficiently than earlier direct current systems. But Tesla continued asking deeper questions. Could electricity move through the environment itself? Could energy be transmitted without traditional wires? And could electrical energy be produced or accessed in ways that did not rely entirely on large mechanical generators? These questions led Tesla into a series of unusual experiments involving high-frequency electrical currents and resonant electrical systems. One of the most important tools Tesla developed during this period was the resonant transformer, now known as the Tesla coil. The Tesla coil allowed Tesla to generate very high voltages while using relatively small electrical input. More importantly, it allowed him to study how electrical energy behaved when it oscillated at high frequencies. During demonstrations, Tesla showed that electrical energy could travel through the air over short distances. Light bulbs could glow without direct wire connections when placed within certain electromagnetic fields. These experiments demonstrated that electrical energy could move through space in ways that traditional power systems did not normally use. Tesla began thinking about how resonance might allow electrical energy to be transferred more efficiently. Resonance occurs when two systems oscillate at the same natural frequency. When this happens, energy can move between them very effectively. Tesla believed the Earth itself might behave as part of a large resonant electrical system. If electrical signals could interact with the natural electrical properties of the planet, it might be possible to transmit energy across long distances. This idea eventually led Tesla to design large experimental systems intended to transmit electrical energy wirelessly. One of the most famous projects connected to this concept was the Wardenclyffe Tower. The tower was intended to test long-distance wireless transmission of electrical energy and communication signals. Tesla believed that by using large resonant structures, electrical energy could be distributed without the same network of wires used in traditional power grids. However, the project faced major challenges. Building large experimental electrical systems required enormous funding, and investors were often unsure about the commercial potential of Tesla's ideas. Technical difficulties also appeared as Tesla attempted to scale his experiments. While small demonstrations showed that energy could move wirelessly across short distances, transmitting large amounts of power over global distances proved much more complicated. Eventually, funding for the Wardenclyffe project stopped, and the tower was never completed as Tesla originally intended. Because of this, many people today wonder whether Tesla had discovered a completely new method of generating power. In reality, Tesla was not trying to create energy from nothing. Instead, he was exploring alternative ways of transmitting and distributing electrical energy. His research focused on resonance, high-frequency currents, and the interaction between electrical systems and the surrounding environment. These ideas later influenced many fields of electrical engineering, wireless communication, radio transmission, and modern resonant wireless charging technologies all rely on principles that were part of Tesla's early experiments. Today, engineers use resonant systems to wirelessly transfer small amounts of electrical power between devices. Wireless charging pads for phones and electric toothbrushes use carefully tuned coils to move energy through short distances without physical connectors. These technologies are not identical to Tesla's original vision, but they rely on related concepts involving resonance and electromagnetic fields. The key insight is that Tesla's experiments were not about discovering unlimited free energy. they were about understanding how electrical energy behaves and how it can move through different systems. Tesla recognized that electricity is not limited to wires alone. Electrical energy can interact with magnetic fields, oscillating circuits, and even the electrical properties of the environment. By studying these interactions, engineers can design new ways to move and manage energy. Even though Tesla's large wireless power projects were never fully realized, the scientific ideas behind them helped shape future technologies. Research into resonance, electromagnetic waves, and high-frequency systems continues to influence modern engineering. The story of Tesla's experiments reminds us that innovation often begins with asking unusual questions, sometimes the most important. Discoveries are not new machines but new ways of understanding how existing forces behave. Tesla did not replace traditional generators with a completely different power source, but he did expand the scientific understanding of how electrical energy can be transmitted and controlled. And those ideas continue to inspire research into wireless energy systems today. If you enjoy exploring the history of electrical experiments and the engineering ideas behind modern energy systems, consider subscribing to the channel. New videos examine the practical concepts behind historical technologies and how they connect to modern electrical design. You can also check the description for a useful reference that outlines some of the basic components people study when exploring small generator systems and experimental energy setups related to these ideas.